So let's go ahead and get started. All right, the first thing we're going to talk about is the area. Hi, guys. If I have to keep stopping to listen to you guys are moving. It's your last warning, okay, Sangha? Yeah. Okay. All right. When we talk about area of a rectangle, we're actually talking about the area of the rectangular region. This is why when we talk about area, we're looking for the size of the entire surface. It is the size of a surface. That's why we call it surface area. So size of the surface. Who remembers the formula for the area of a rectangle? Labib?
It's the length times width.
Is length times width. Yeah, that's perfect. Is length times width. So let's go ahead and put that down. Maybe we'll put it down. The pencil doesn't seem to be penciling at all. I broke my pencil. Let's see if that fixes it. All right, so the formula for calculating area is length times width, which sometimes you'll put as L times W. We will also call it base times height sometimes. In the homework, there will be a section that tells you the base and the height of a rectangle. All that is just length and width. All right. Does anyone remember how to calculate the perimeter of a rectangle? Remember, perimeter is just the length of the outside. Someone besides Labib, because he got the area. EJ.
2L plus 2.
Yeah, it would be 2 times your length plus 2 times your width. In other words, you're adding all of those digits together, right? It'd be this plus this plus this plus this. 2L plus 2W is like the standard for it, but a lot of times you just in your calculator, you just do 6 plus 6 plus 7 plus 7, depending on what your lengths are. But that's basically what we're going to talk about today. It's just length times width is our area, and then we multiply add all the sides together, and that will be our perimeter. So let's look at this first example. We're supposed to find the area and perimeter of both of these rectangles. Can someone tell me the area of this one with the 4 and the 9? Yeah.
36
It'd be 36 centimeters. Would it be just regular centimeters?
squared.
It'd be centimeters squared. Because it would be 4 centimeters times 9 centimeters. Well, 4 times 9 is going to be that 36. And centimeters times centimeters would be centimeters squared. Don't forget about the squared above that centimeter. So that's our area. Someone new, tell me the perimeter. What is the perimeter of this rectangle? Someone's new. Someone new.
26.
It'd be 26. How'd you get that?
9 plus 4, then times 2.
Times 2, yeah. I'm going to put it like we had it up there. I'm going to go like 2 times 9 plus 2 times 4, which is going to equal 26 just regular centimeters. In other words, it's just 9 plus 9 plus 4 plus 4. Or, like Alicia did, she did 9 plus 3 times 2. Either way, it all works. Just make sure you have the sum of each one. Oh, boy. That one only has one measure on. So if this is 35, what's this bottom one then?
35.
It's also 35. How do I find the height, John?
You use the inverse tangent.
Not quite the inverse tangent. We're actually going to use regular tangent. Inverse is finding an angle. Regular tangent is for finding the side. I'm going to move this 18 up here. I'm going to use my alternate interior angles to say this is 18 degrees. So we have to use trigonometry. And John already told us we're using tangent. So just a quick rehash on trigonometry. We have SOHCAHTOA. SOHCAHTOA. That means sine is opposite over hypotenuse. I don't know the opposite. I don't know the hypotenuse. That probably won't be good. Cosine is ka. That'd be adjacent over hypotenuse. Well, adjacent is 35. Hypotenuse, I don't care about that length. And then tangent is toa. That is opposite, which would be that x, over adjacent, which is 35. So yeah, in fact, we're going to use tangent. So tangent of a given angle, in this case it's 18 degrees, is going to equal opposite, which is x, over 35. All right, now we just want to get x by itself. I need to get rid of this dividing by 35. What do I have to do to this side to get rid of that 35? Victoria? Multiply by 35. But what I do to one side, I have to do to the other side. So we're going to end up with x equaling 35 times tangent of 18 degrees. And I don't know about you, but I don't know that offhand. Well, I do actually know it offhand. But you don't know that offhand. So we should all be taking our calculators out and making sure that we can calculate this. And what does this come out to? What does this come out to? Usher? 11.4. So we'll have x equals 11.4. So that means our height is now 11.4. Knowing that, can someone give me the area? Libby, what is the area of this one?
Could you round it to the nearest number? Or nearest whole number?
The nearest whole number? Yes. In fact, that brings up a point. Did you see I put an equal sign here? I shouldn't have. I should have put an about symbol because it was rounded. All right, so what's the area?
Well, I did by 11, so the area should be 85.
Yep. Who did it with the 0.4? Could someone give me the 0.4 because that's what I have down. Yeah.
399 centimeters.
399 centimeters squared. Thank you for adding that centimeters squared. Labib, yours is definitely not wrong because I didn't tell you where to round it. I just had the 11.4, so I'm going to give the answer with 11.4. All right, can someone tell me the perimeter of this bad boy? Jacob. 92.8 centimeters. Is that squared? No. Yeah.
When you're in that problem when you're talking about the area and the perimeter, would you also write those as approximations?
I would not put approximations. You could, absolutely. But what saves it in the work is I told the person reading this I approximated this number. So now they know I didn't approximate it any further. I actually give like the actual values based upon this approximation. Generally, you're going to save approximations for if I use that 11.4 and this one needed to be rounded again, then I'd put approximation again, letting them know that I approximated this one, and then this was an approximation of the approximation. Does that kind of make sense? All right, that is area and perimeter of a triangle. Remember, we can use SOHCAHTOA, we can use 60, 30, 90, we can use 45, 45, 90 as well. But you can always use SOHCAHTOA. So if you're like, I don't remember 60, 30, 90, you can always use your SOHCA and TOA. All right, all this one is saying is, hey, if you got a big structure where you're calculating the area for it, you can calculate the area for the smaller sections and just add the two things together to get the whole part. Now, the cool thing is these would have to calculate triangles. We're not going to talk about triangles today. We're just going to talk about rectangles. And so applying this to a rectangular shape is what we're happening here. We are going to find the area of everything inside of this, but we're going to do it in two different methods. You never know which method is going to be the best. It depends on the situation. So the first method I am going to use, I'm going to break this apart into small rectangles that I can actually get the measures of. So let's start at the top. What I'm going to do is I'm going to cut that top off into this rectangle here. Actually, is that the best one to start off with? Let's not start there. Let's start even easier. I'm going to start at that bottom left one. Let's start with the very easy one. What is the measure of this rectangle in the bottom left? Labib. It'd be 3. It'd be 3 times 1, which would just give me 3. All right, now let's just do the box right next to it. This one right here. First of all, everyone look up here real quick. Is from here to here 11? No. So what I do is as soon as I break one of these boxes apart, I let that affect my entire drawing. So I say, well, okay, from here to here is 3. So that means that new box that I drew would be 11 minus 3, which would be 8. So the area of that box I just drew would be 8 times 6. which is going to equal 48. All right, now let's do that little box right above it. Can someone help me out with this one?
It's 4.
It'd be 4. How'd you come up with the 4?
Because the bottom of the rectangle is 8, and then on the right side it's already 4 and 4, or 8 minus 4.
Yep, so we have a 4 and we have a 4, and I bet you realize this had to be 1, right? So this little thing is 1.
Wait, how do we know that's 1?
Oh, we know it's 1 because of this 6.
Oh.
Well, if we go across, this 5 has to go all the way across, so that must be 5. So this must be 5. All right, so that's 4 times 1, which is just 4. And that top rectangle is going to be, 5 times what? 10. It would be 10. That'd be 10 because the 6 plus this 4 would be 10. So we would have 5 times 10. Let's put that back in red. Which means we just have to add these together. So our total area is going to be 3 plus 48 plus 4 plus 50, which should be 105. They don't really give me units, so I guess we could put units squared. You could put centimeters squared. You could have just put 105 since I didn't give you any units as well. Okay, that's one method. One method is to divide it up into little rectangles. Here's the other method. Turn it into one big rectangle and subtract all of the extra stuff away from it. So my example is going to happen over here. Let me just use green. So if I wanted to make this a giant rectangle, I would do something like this. And then I would try to get this measure here and get this distance here. Can someone come up with this height? Can someone get this height for me? Emma? It won't be 11.
Oh. Sorry.
That's okay. It's 12. It's 12 because this length is 6 plus this length is 6. This is going to be 12. All right, what is our width? Slightly harder. What is our width? Jacob?
14.
How'd you get 14?
So that 3, so you can subtract that 3 from the 6,
Mm-hmm.
and then that gives you 3, which is the leftover, to add to the 11.
And add it to 11. Perfect. So Jacob basically, he said, okay, I got this 3, which makes this distance 3, which makes this distance 3. Oof, that's a terrible one. Which makes it 11 plus 3, which is 14. All right, now what we're going to do is we're just going to get rid of all this extra waste. So this waste is just 6 times 4. So we'll have 6 times 4, which is going to equal 24. Then we do have to divide this one up a little bit. Note that this distance here would be 3. So inside that little box would be 3 times 1, or 3. What is the area of this one here? What is the area of this guy here? I know it's 6 times something. I know it's 6 times something. Babe, you think you got it? It'd be 36. So this distance would actually be 6. One way you could come up with that is this right here is 1, which means this has to be 6, because 6 plus 1 plus 5 is going to give me my 12. So that is 6 times 6, which equals 36. So we're going to take our total area, and that is that 14 times 12. And then we're going to subtract away all that little excess stuff. So that'll be minus 3, minus 36, minus 24, or 24, which will equal 105 units squared, once again. Like I said, it's not necessarily easier to use one or the other all the time. Just know both of them, because sometimes you won't be able to get like an inside, and you go, let me try the outside way. Sometimes the outside way is easier, sometimes the inside way is easier. It all depends. And it depends on personal preference, what one looks nicer to you. Labib.
Couldn't you, how come it wouldn't work if you did 14 times 12 and just like leave it like that? Because it's still the same shape.
It wouldn't be the area of the inside. So I'm looking for the area of the inside. So if I just did, so I'm looking for, I guess, this area here. That's all I want. I want to know, like, basically how much concrete do I need to fill this path. Now, if I'd go to ACE and say, well, I'm just going to do 12 times 14, I'd buy enough concrete to fill this entire thing. Maybe not terrible, but you're going to pay a bunch of money for concrete you don't need. Yep. So we're just calculating inside the shape that they give us. Okay? Other questions? I do want to note, 1 through 15, it does say odds. You can just do odds. I did put all of the answers on the answer key, so if you go further and do the evens as well, those answers will be on the answer key. But you're only required to just do the odds for 1 through 15. They're all there, so you can fill them in, but you can also just take every even one and just cross it out if you want to. All right, otherwise, the rest of the time is yours. Ask questions as need be.